مرحبا، كيفكم جميعا؟ نحن أخذنا day off يوم الجمعة بسبب بعض الظروف اللي صارت يعني. إن شاء الله تصير الظروف أحسن علينا وعليكم. يوم الجمعة كان مقرر إنه نخلص شيت complex 3 exercise number 3، بس ما سمح لنا الوقت، ما سمحت لنا الفرصة، ما راح أسمح لأي حدا إنه ياخد منكم ولا أي حصة ولا أي دقيقة وقت فيها بتتعلموا وبتأسسوا فيها نفسكم ومستقبلكم. لأنه هيدا المستقبل لإلكم، هيدا البلد لإلكم، لإلنا، لأولادنا، لكل الناس. إن شاء الله يا رب الظروف تصير أحسن. الحصة يوم الجمعة رح أعرض لكم إياها بهذا الفيديو القصير، وإن شاء الله يا رب يكون بكفي يعني. exercise number 3 اللي ما خلصناه بالشيت يلي هو بدرس الكومبلكس المطلوب ومهم جدا للاختبارات مثل ما سبق وحكينا. اختباراتكم الأسبوع الجاي راح يكون في شيء شرح مفصل يعني. وأنتوا إذا في عندكم أي اكسرسايز أو أي استفسار أو أي شيء رقمي معكم، احكوني على الابلكيشن، على الواتساب، بأي وسيلة. بفضل على الابلكيشن تاعت المدرسة أو على الواتساب على الجروب اللي عاملينه تبع grade 12. ما في أي مشكلة. Anyway, let's start by number 1. If pi over 6 is an argument of z, then an argument of I over z bar square is which one of this? So argument of I over z bar square is equals to argument of I minus the argument of z bar square, which is equal to argument of I minus 2 argument of z bar. But we have a formula or a property says that if argument of z bar is equal to minus the argument of z, that's a property. So we may write here it's equal to argument of I minus or plus 2 the argument of z, which is equal argument of I, we know that it's equal pi over 2 plus 2 times pi over 6. That's why it's equal to pi over 2 plus pi over 3, and it's equal to 5 pi over 6 modded 2 pi. So the first answer is D, and we choose D. If z equal minus radical 3 plus ei pi over 6, so we write z equal minus radical 3 plus ei pi over 6, so it's cosine of pi over 6 plus I sine pi over 6. So it's minus radical 3 plus radical 3 over 2 plus half I. So it is equal to minus radical 3 over 2 plus half I. That's z. So now we can find modulus of z, which is equal to radical 3 over 2 square, it will be 3 over 4 plus 1 over 4. So it is equal to 1. And then tangent inverse of half y over x, radical 3 over 2. Tangent inverse y over x. And in absolute value, so we remove the minus, it's equal to pi over 6. But z is in quadrant 2. Why quadrant 2? Since it is negative, positive. So negative, positive. So it's somewhere here. So it's in quadrant 2. And then the angle is pi minus alpha, which is equal, the argument of z equal pi minus pi over 6, and it's equal 5 pi over 6. So z equal at the end 1 ei pi over 6, 5 pi over 6, and the answer is it's A. EI 5 pi over 6. We have z prime which is given. It's equal to 1 or it's equal to z minus 1 over z bar. That's given. He's asking about what's the module of z prime where z module of z equal to 2. So it is equal to, taking same denominator, so it will be z bar minus 1. But we have a property says that z bar equal to modulus of z square. That's a property. So it's equal to modulus of z square minus 1 over z bar. Now when we make modulus of z prime, so it's equal to modulus of z square minus 1. Why? Since it's a real number, modulus of z square is a real number, minus 1 is a real number, over modulus of z bar. That's equal modulus of z square minus 1 over the modulus of z. Also there's a property says that modulus of z bar is equal to modulus of z, and that's equal, modulus of z is given, which is 2, so 2 square minus 1 over 2, this is 2, so it's equal 4 minus 1, 3 over 2. So the answer is C, it's 3 over 2. Complex number with modulus z equal radical 2, that's given. Okay. Then modulus of z bar plus I z bar. So let's take z bar common. Simply it is equal to modulus of z bar times 1 plus I. And it's equal modulus of z bar times modulus of 1 plus I. So it's equal to modulus of z, z bar equal to z in modulus z bar equal to modulus z times modulus 1 plus I, it is radical 1 plus 1. So it is equal to modulus of z is given radical 2 times mod radical 2, which is equal to 2. So the answer is B, simply enough.